Welcome everybody on another peer review club, and today we have PR 27374, which is a slight bit of logic change around net grouping and how the core node connects to different outbound PR. And the peer author is among us today, and she will be guiding us with the concept and the questions. So let's get started. Stratos, for the stage is yours.
Yeah. Okay, so I think first we should go through some basic stuff. Like what are the different connection types? What are the different net groups? And what are the different networks?
Yep. Okay.
So that all of us are on the same page before we delve into the PR itself.
Let's do it.
Yeah. So what are the two main connection types? We covered this before.
Inbound and outbound.
Yeah.
Okay. Yeah, that was easy.
Yeah. So that's the two main connection types. Yeah. Outbound has a lot of other different connection types, like outbound full relay, manual, feeler, block relay, adder fetch.
Right. So inbounds are always like only full relays?
Yeah.
Okay.
Inbounds it actually depends on the other. What does inbound connection mean? The other peers initiates it, right?
So it's up to them how they are initiating it. They could initiate as block relay only also.
Yeah, they could. Like we don't know.
Right. Makes sense.
Yeah. So these are the different kinds of, like, we don't need to worry about inbound. We are mostly concerned about outbound connections in this PR. So like outbound full relay is what you said. Like the main three things which are gossiped in the P2P network is address, transactions, and blocks. So outbound full relay gossips all of them.
Okay.
And we have, these are like 8 automatic connections which our node initiates to other peers.
Right.
And the default max limits for outbound full relay is 8.
Okay. And the node will mostly try to like have all the 8 connections.
Yeah.
And yeah. Okay.
And inbound it's 117, I think. I'll have to check. So around that. But yeah, we have 8 automatic outbound full relays, and we'll be mostly focusing on this.
Okay.
In this PR. Yeah. And then we have manual. Manual means like we can use that add node RPC command and initiate a connection, like an outbound connection.
Right. But then we can initiate different kind of outbound connections with it also, right? Like block relay, full relay, only address. Because add node has a permission thing. I think we talked about it a few weeks ago.
Yeah.
Right.
Invite listing.
Yeah. Oh no, it was in whitelisting. Add node probably is something different.
Yeah, I don't remember the exact. What is that PR about? Whitelisting for inbound or outbound?
It was about whitelisting for outbound connections.
Yeah, so we currently don't have support for that. PR hasn't been merged, so we currently don't have support to make it block relay. Yeah, so that's manual. And then we have feeler connections. And feeler connections are just short-lived connections which you make to peers to know if they are online or not.
Okay. So you just check whether the peer is alive and then drop.
Yeah, so that our address manager. Our address manager is what we'll be calling it adderman. So if you hear the word adderman, it means address manager. It's actually the file peers.dat in your .bitcoin folder.
Okay.
So that's the adderman or address manager. So we need like nice addresses with which we can connect to in the adderman. So feeler is one of the logic which will populate the adderman with addresses which we can connect to and are online.
Okay.
And then there's block relay.
That
block
only
relay,
relays the blocks.
Yeah, it only relays the blocks. And then we have adder fetch.
And that only fetches the address.
Yeah.
Okay.
That's an interesting story. Like, which do you think came first? Like, before in the earliest client, there was only inbound and outbound.
Okay. No categories
Right?
like this.
Yeah, no categories like this, nothing of this sort. Then they introduce adder fetch. Like adder fetch is like when your node first bootstraps, like you'll connect to the DNS seeder, right? That's it pass and all those 7 special things. And you'll get all the peer addresses with which you can connect to and make connections. So only for that scenario, you use adder fetch connections to connect to DNS
new
seeder.
addresses. Yeah.
Yeah, and you only get the addresses and then it stops. Then you do not use adder fetch again. So,
Okay.
So this was introduced first. Then feeler came when the Eclipse attack, that stuff happened. Ethan Hillman's thing. Then manual happened. Like manual was always there, not always there. It got added, but then it started getting treated as a separate type after the feeler. And then block relay is a very recent thing.
Okay.
It is the last added one.
Okay. So the adder fetch. So the adder fetchers are like peers we are just connecting to on short leave and just asking for addresses. We don't do anything else with them.
Yeah.
And why do we need a separate adder fetchers, like separate connections like that, just to fetch addresses?
For like first we need to like when you just start a fresh node.
The initial stage when you don't have anything, you need to get some addresses. So the connection to the DNS seeds is kind of like an address fetch connection.
Yeah, it is an adder fetch connection.
Okay.
That's the only place where it's used.
So later on, we never make connections like that to regular peers.
No, we don't.
Okay. Okay. Cool.
Yeah. So this is our outbound connections, and like this is what we have control over. Inbound connections we do not have control over. So it's possible that it could be attacker controlled. So whenever we make outbound connections, you have to make sure that it's from as diverse IP ranges as possible, so that like Eclipse attacks and things like that don't happen. We need a good peer diversity.
Right.
For outbound connections. So that is the different kinds of connections. So that's the first concept.
Right.
Then there's another concept called like how do we find diverse IP addresses to connect to?
Okay.
So that's using GetGroup.
Yeah, this is inside netgroup.h. I think netgroup.cpp will give you the definition.
Yeah, before. Yeah, so basically, like, yeah, so we want, yeah, so what is GetGroup?
So what I understood so far is like GetGroup is a function that takes in a network address and tries to give it a canonical string that identifies it as a group. And then if two addresses are very far in terms of IP range, the string identifier will also be very different. When they are same or close, the string identifier will be close. But I don't exactly understand what exactly the string identifier, how do we get the strings, and how they are different, how they differ with IP addresses.
Yeah, I can tell that. Like, suppose we have an IPv4 address. Like an IPv4 address is what? 4 bytes, right? So 192.163.175.1, let's say.
Right.
So this is 4 bytes. So this is 1 byte. This is second byte. This is third byte. This is fourth byte.
Right.
Okay. So if you print to the get group of IPv4, it will actually print the first byte which will be printed is the network class of IPv4. So that's 1 for IPv4, 2 for IPv6, 3 for Tor,
Okay.
and like that. And then you will print the first 2 bytes actually of the IPv4 address.
Okay.
So whatever 192 is in hexadecimal, those get printed here.
Okay.
So so this is like what, 1 byte, and this is also 1 byte. Right? So the variable bytes are 2 bytes in an IPv4 address.
Right.
Right? It's just the same this byte which is getting copied.
Okay.
So what does that mean? If it's 2 bytes, how many possible groups can be there for IPv4? 2 bytes means 16 bits.
Right. 2 to the power 16.
Yeah. So there are 2 to the power 16 possible groups for IPv4 addresses.
Right. Yeah, Anmol, you had a question?
No, I was just going to answer that.
Oh.
It's 2 to the power 16.
Yeah. So that's IPv4. Then if you take IPv6, it's again the network class. For IPv6, it's 02. And then it will be the first 4 bytes.
Okay.
Of the IPv6 address.
Okay. Maybe you need to scroll down the screen a bit.
Oh, yeah.
Yeah.
Yeah, so IPv6, the GetGroup will return some hexadecimal, 0 to, hexadecimal bytes, whatever it is. It would look something like this, and next 4 bytes.
Okay.
So I have actually written a blog for it.
Oh, cool. That would be really nice to put into the description of the PR.
Yeah, it might be easier to read from there. Yeah, this is the logic translated into Python so that you can easily understand. So, yeah, this is what I said right now. Network class of IPv6. Like what this GetGroup prints is the network class of IPv6 and the first 4 bytes of IPv6.
Right.
So that means there are
2 to the power 32 possibilities of NetGroups. Okay.
Yeah, and then similarly for Tor, like it's just the network class of Tor, and
first 4 bits of the Tor, and then last 4 bits is set to 111. Only the first 4 bit is user. Okay, so the logic follows very similar to like IPv6, but the last 4 bits are like 4 bits or 4 bytes.
It's bits, not even byte.
Okay, so
we can only store a byte in a computer program, right? So that's why we are filling the last 1 byte is 8 bits. So the first 4 bits is from the Tor. It's actually not the Tor address. I should correct this. It's actually the public key.
Okay.
Like, in Tor, like all these addresses
are public keys basically.
Yeah, they're public keys. So in the C++ program, we translate this into a public key, and we get, and so it's actually the first 4 bits of the public key of the Tor address.
Okay. But that like the point of this entire PR is like that's not a meaningful categorization for Tor because public keys are basically random numbers. So it's a formatting at the start.
Yeah.
Okay.
Yeah. So Tor is this network class, and the next 1 byte we know, like the first thing is the 4 bits, and the last 4 bits we always set to 1111.
Okay.
So that means there are 2 to the power 4 possible net groups for Tor.
Right.
So that's just 16 possible net groups.
Okay. That's pretty low.
Yeah. And similarly
Same
for I2p.
For I2p. Okay.
It's 4, then the first 4 bits. For I2p, it's actually the address itself. Only for Tor, we use the public key. For I2p, it's actually the hash of Like you cannot get the
Whatever that thing is,
Yeah.
basically random numbers.
Yeah, exactly. So this is also 2 power 4. And cjdns, it's also like, yeah, so the problem with cjdns is they always start with fc.
Mm-hmm.
Like any cjdns address will always start with fc.
Okay.
So fc is 1 byte, that means 8 bits.
Mm-hmm.
So we will take the next 4 bits also.
Okay.
So that is next 4 bits is 4. So that's why we take the first 12 bits. But even in the first 12 bits, the first 12 bits is FC4, but FC is always constant. So only the last 4 bits is like the last 4, that is this 4 is the only thing which is going to vary. And this is 4 bits. So even here it's only 2 power 4 possible net groups.
Okay.
Yeah. So that's how we do the get group logic.
Mm-hmm. And this is happening inside that one big giant get group function in code.
Yeah.
Okay.
Yeah. This is a Python code for that.
Okay. Okay, cool.
Any questions?
Yeah, I have a question.
Yeah.
So in Tor, I2p and cjdns, they're all the addresses are all derived from public keys. So we can't actually do some meaningful grouping there, right?
Yeah, exactly.
Okay. So then, why are we trying to group them?
Good question. Yeah, that was my next question. Like, why, like somebody took an effort to like categorize net grouping for I2P and Tor?
Yeah. So thing is, yeah. So we talked about the adder man, right? The address manager.
Mm-hmm.
Yeah.
So and it's just 2 tables, actually. It's made of the new table and it's made of the tried table.
Okay.
Okay. So what the new table does is it's all the fresh IP addresses which you heard about, like from other peers, but you have not attempted connections to it.
Okay.
So all those are stored in the new table.
Mm-hmm.
In the tried table, you store all IP addresses of peers with whom you have attempted connection.
Right.
So those are the 2 kinds of tables in address manager. So when you get new IP address, you have to store it in the address manager.
Okay.
Right? Because that is from where we get the addresses to connect to.
Right.
So in the storing logic of the address manager, we actually need the get group. Like, we use this grouping logic to find the like where to store it.
The bucket to store that address in.
Yeah, exactly.
Okay. So in order to be compatible with that logic, they had to implement a grouping for Tor, cjdns, and I2p also, even if like it semantically doesn't make any sense.
Yes.
Okay. I also had the similar question. Like, yeah, why not just ignore for those groups?
Yeah.
And yeah, okay, that's the problem.
So I have a follow-up to that. So for Tor, the last 4 bits are set to 111, right? So instead of that, if we set the bits from the address itself, that will solve this problem also, right? We wouldn't need to ignore Tor addresses because every Tor will basically become 2 to 8, right?
Yeah, that's a very good question. So I think I asked the same question and somebody else made this suggestion. Yeah, so basically there are 2 problems with it. Wait, I'm trying to think.
Can you rephrase the question again?
So this PR implementation done is that we ignore this get group when it is a Tor address, because
we don't ignore it, right? We do calculate a group and we do the grouping logic with that output also. Or I'm getting confused, or if you meant something different. I think like we don't ignore the group, we still calculate the group of Tor and do whatever the bucketing algorithm needs to do with that group calculation for Tors and I2Ps. But the point of having a group is like to separate addresses into different buckets which are like distant from each other, but that conceptually doesn't make any sense in Tor because you have basically random numbers as addresses, unlike in IPv4 IPv6, where if something is 192.165, then if two addresses are both 192.165, you can say like, okay, they probably are close together in same geographic location. But such comparison is not feasible for privacy addresses. So that created the problem.
Yeah, so like the current PR which we are talking about, we to ensure a diverse net group. Basically, we don't look at the grouping that NetGroup does, right? Because it doesn't make sense to just group random IP addresses together. And so my suggestion was, why don't we make it more random by changing the GetGroup function so that it will never group random addresses together. I mean, reduce the probability.
So I think it's telling like increase the number of get groups. Like right now we have 16 possible groups for Tor, I2P, and cjdns. So you're talking about increasing it.
Yes, yeah, to 2 raised to 8 will be right. Yeah, 1 byte.
Yeah. Like the first reason what Raj told, like that's the one thing is that we want to avoid this get group thing. Like what Raj told was right. That is the first reason. Like it doesn't make sense in Tor, I2P, and cjdns to even do the get group thing. The second thing is that if you actually increase the bits, it messes up with the Adderman fraction. Like it messes up with how the address, like how Tor, I2P, cjdns addresses are distributed in the Adderman, and we don't want that. So
that's a good point. So we are basically not changing the get group algorithms on Tor. So for Adderman is still calculating groups for Tor's I2P cjdns like they used to do before, right?
Yeah, like like for example, if you get a Tor address and like you heard about it from another Tor address, so the source of the address you heard is Tor and your current address is Tor, like it's right now it's possible that only 1/4 of the new table can be occupied with these kind of addresses. So if you change it into something else, like even 5 bits, not even 8 bits, even if you put it 5 bits, it will mess up the Adderman fraction, and these kind of addresses can get filled in the entire Adderman. And we do not know the effects it would have in picking up new peers to connect to and things like that. So it's something that people don't, it's a kind of thing that people don't really, usually don't go and change because we do not know the effects.
Okay, seems like a lot of complicated nuances going around. Yep.
Yeah.
Okay, that answers it. Thanks.
So if you want to change it, like we need to give a better reason. Like why should we change it?
Yeah. Okay, let's move ahead with the questions then.
Yeah.
On the next part, we had any other concepts that you want to talk about?
No, I think those are the two main stuff. The net group, the peer diversity, and the different kinds of connections.
Okay, cool.
So yeah, we answered this. What are the different types of outbound connections? And can you point the region in the code where these connections are established?
Yep.
So yeah,
that would be cool to look at. And I think I've also found it, but I lost it now.
So it's thread open connections itself.
Okay.
And I think inbound connections, it's some other thread open added connections. So inbound connections get called in thread open added connections, and all outbound connections, that's what we're looking at right now. It's dealt with in thread open connections.
Okay.
And it takes an argument or string, a vector of strings. So this is the stuff with which we want to establish manual connections to. Like if we specify add node and tell that we want to establish manual connections. So that's what connect contains.
Okay.
So before we even enter into any automatic outbound logic, first itself they establish the manual connections here.
Okay.
Connection manual, they iterate through all the stuff in the connect and they just establish this manual connection.
Okay.
So this, yeah, it doesn't affect our NetGroup diversity logic. Like we are worried about the 8 automatic outbound connections. Like how do we decide that?
Mm-hmm.
Yeah, okay, we look at that later. So yeah, that's where it's established. What's a NetGroup? Why is NetGroup diversity important when making an outbound connection?
Mm-hmm. Anybody want to go ahead with this one?
I think it's to prevent eclipse attacks. Right? So usually, if it's the same person, then they'll be in the same network group, and unless they're like super rich, they can. Yeah, but yeah, it's more probable that it's in the same.
This reminds me of linking line. Did you read the blog post? Teamwork. This is another active attack. So they had these IP addresses in these ranges.
Okay, and they were doing what?
Yeah, it's an active attack. Like
okay. So they were trying to like connect some. They were like trying to connect with lot of nodes and trying to find the source of transactions, something like that.
Yeah. So in way they're in the like. I just wanted to show the IP address. Like the ranges are usually close.
Okay.
Active attacks, eclipse attacks. Yeah.
Because it's also hard for an attacker to get a lot of like very diverse and different ranges of IP address also.
Yeah.
Mm-hmm. Okay.
IPv4, IPv6.
Mm-hmm. But same thing again, it doesn't apply for Tor because you can like keep rotating around addresses.
Yeah, kind of the same difficulty, I guess.
Okay, cool.
Yeah. And then how is NetGroup diversity maintained when establishing outbound connections?
Yeah. I think this points to a very interesting part of the code, which I might not fully understood. And yeah, this is your previous PR on top of which this PR is a follow up on. And can you like go through this logic once and like bit explain like why it was done in this way and what changed because of this?
Yeah. This is like I actually revived Gleb's PR. He made it long time ago.
Mm-hmm.
So basically, this was the old NetGroup logic. This one on the left side. So before you used to, so there is this vector called setConnected.
Okay, what does setConnected do, and what does it mean?
Yeah, so it stores groups of IP addresses.
Okay.
And it stores netgroups of IP addresses, and you want to connect to netgroups which are not already included in this.
So setConnected means like a set of netgroup for all the connected peers that we have currently and have seen before also. I'm just guessing.
Yeah. So supposing like IPv4, we know 0, 1, and 2 bytes, right? So supposing we have 0, 1, 2, 4, 6, 7, 0, 1, 3, 4, 7, 8. Something like that in setConnected. Like this is what, like supposing we're connected to 2 pairs and these are the groups which it contains.
Okay. Okay.
So if you get another IPv4 address starting with 0, 1, 1, 2, 4, 6, 7, like if it starts with 192.163, then it will not be inserted into setConnected.
Okay.
Basically, that means we will not connect to any more IPv4 address which starts with these first 2 bytes as 192.163.
Okay. Okay. So setConnected is our way to track of all the connected connections group, and we want to connect for a new connection. We want to select a new group that is not already inside setConnected.
Yeah.
Okay. Makes sense.
Yeah, like this is the vector is initialized. Oh, this is the changed one. Yeah, so see, you can see that before you make an outbound connection, like if at all you have encountered the get group before in setConnected, like I'm making a new outbound connection and then and the IP address of it is 192.163.180.2. So when I reach here, I will see that this count is like it will return 1. So that means I will break. So the connection actually gets established here. So we will not open a connection to a pair which starts with 192.163 because of setConnected.
I had a question on this line. Why does it break and doesn't continue on the next peer? Because if it's not reachable, then it's continuous. So I suppose it tries the next one in its list.
I saw this exact same question on Stack Exchange. Did you see it?
No.
Okay, lightly answered it. I mean, I bookmarked it and kept. I didn't read the answer though. Like I didn't understand it. Wait, can I see?
That would be interesting to see.
Yeah, this one. Okay, this is something else. But he's talking about, the question is where you have to use break and where you have to use continue.
Right, yeah.
So here they're saying a break fully restarts the search for an outward connection, the type which will be determined again. Also, new incoming potential pairs will be included in the Adderman tables. A continue effectively just asks Adderman for a next candidate from the existing tables.
Okay. And yeah, my question is about the choice of break versus continue in 2 cases. And the answer is something not very easy to read, but seems
I'll
like.
have to think more. Yeah.
So what I think is, well, I don't know. Maybe it's because if there are 2 addresses in the same net group, that means already some kind of attack maybe is going on. So we'll just scrap all the addresses we have and we'll start again. And already like the manual connections will already be made right before this. So could it be that we're discarding everything because we found a match? Something.
Could be. Yeah. Also, like, yeah, it will be good to like have this answer also like scoured in a bit detailed, and if we can answer it, cool. We can also put it in our discussion page and try to flesh out this answer in and make it a bit clear. Okay. Cool.
Yeah. So what are we talking about? Oh yeah, this one. Yeah, so we want to get groups which are as different as possible from our existing peers. So before they used to add, like they used to consider peers. Like anyway, we shouldn't consider inbound peers because inbound peers are always attacker controlled. I mean, always attacker controlled from a security point of view. I mean, they are not necessarily attacker controlled, but yeah, we do not consider inbound peers at all when we make diversification. And yeah, and so before we wouldn't think about manual peers either, because a manual peer is someone we kind of trust and we expect them we expect them to be honest.
Right.
Yeah, so that was the reason before we did not consider those two peers for NetGroup.
But now we are considering manual.
Yeah. So now we are saying we avoid inbound because it's attacker, like something an attacker could make.
Yeah.
We avoid adder, fetch, and feeler because they are
Short-lived
connections and they shouldn't affect how we make persistent outbound connections, which are going to last a long time. So that's why we moved adder, fetch, and feeler. Like they shouldn't affect our outbound pair diversity.
Right.
Outbound full relay and block relay before and after, like that should affect. Those are real pairs, persistent pairs. And now we consider manual too because two reasons actually. Like if you look from an adderman's perspective, it doesn't know the difference between manual or outbound or block relay. Like all of these are persistent connections. Adderman won't be able to differentiate between all these three connections, right?
Okay.
Like we will be able to differentiate, but for the Adderman, it's the same.
Yeah. Okay.
That's one reason. The second reason is, so we kind of trust the manual peers. So they're kind of honest and safe, but it's possible to have ISP level kind of attacks. Like, I mean, the ISP could attack multiple nodes from one group.
Yeah, so, could be.
Yeah, so for that, now we are considering manual in this setConnected. So
okay.
we would create persistent outbound connections to peers which have different net groups from manual, outbound, block relay now.
Okay, clear. That clears that up for me. Yep.
Any questions?
Nope. So far, I'm good.
Yeah, I have a question. So, if you are connected to a peer, say in XYZ network, and I try to manually add a peer who is in the same net group, then will the original peer get dropped, or will we have both connections?
Yeah, like manual connections, it's done in the very beginning.
Before even checking any net grouping logic. So yeah, if I tell it manually to like replicate, like if I tell it manually to connect to another address that is also inside setConnected, it will just do it.
Yeah, like if you connect to XYZ group manually 2 times, since it's a set, it will only get added once. It will not affect how you make manual connections because manual connections is done right in the very beginning, immediately when you enter into the thread open connections loop.
Right.
Does that make sense?
Yeah, thanks.
Yeah. So that's how NetGroup diversity is maintained. Yeah. So all the problems started because the manual got moved in.
Okay, so that was like one grainy sand that changed all this thing. Okay.
Yeah. So that's where the PR started. So did you review the PR concept act?
Yeah, I think a concept act for me, and yep, seems like a good one. But I was like thinking about like how can this behavior be tested, but didn't came up with any good answer. So I think also that's included in the question. Yeah, what's
Yeah.
your review approach? Oh, okay. I was reading it as a what was the test approach, and yeah, it could be interesting to think about testing situations. Like you kind of have to like start a lot of Tor I2p servers and connect with them and check that 2 to the power 4 grouping logic is not hit anymore.
Yeah. Yeah. Maybe before that, we should talk about the problem 27264 introduced.
Okay.
Like this one. Like Tor, like we saw before that Tor I2p cjdns only has 16 network groups,
Yeah.
right?
Yeah.
So, and Bitcoin allows 8 manual connections, 8 outbound full relay connections maximum by default. We saw that manual connections were made. Manual connections were made, yeah, in the very beginning. I'm scrolling up and now scrolling down. And block relay and outbound connections are made here. So there's a connection type here. So all the other kind of outbound connections, block relay, adder fetch, feeler, and outbound full relay, all of them get done here. We are only worried about persistent outbound connections. So that's basically outbound full relay and block relay.
Okay.
So if you, if you want max outbound, what is that variable called? Max. I want to know the max block relay.
Yeah. Max block relay only connection.
Yeah. So max block relay is only 2. Then this is add load. Manual connections maximum is 8.
Right.
And full relay is 8.
Right.
And we saw the order in which they get called. So
add node gets called first.
Yeah. So all 8, it's possible that in a scenario all 8s could belong to different net groups. Then after that you make outbound and block relay connections. So where do they decide the type? Yeah, so it depends on some time. So we don't know, like outbound and block relay, they happen simultaneously, like till the slots get filled. Oh, sorry, it's actually opening block relay connections get the highest priority. Oh, then we open outbound full relay until we meet our full capacity. Then we open block relay until we hit our block relay only. Oh, so there's something called anchor connections.
Yeah, anchor connections are like connections that get persisted through system startup.
Yeah, and they're stored in anchors.dat. That's another file like peers.dat. So you store those peer addresses there. And so if your anchors.dat has some IP addresses, so when you start up your node to prevent Eclipse attacks, like these are reliable peers or maybe reliable peers. So, so you always start making these block relay connections first. Like the anchor connections are block relay connections. You do not gossip transactions and stuff because you don't want to leak IP addresses.
Okay.
And it's not always there, but if it's there, you open those first. Then we will open outbound full relay till all 8 slots are filled. And then we open block relay till 2 slots are filled. And then they try opening additional
outbound full relays. Yeah.
Yeah, this is staying there. And then if it's time to start an extra block relay, then you do it. Yeah, so that's the order in which they get called. So yeah, anyway, the problem is like if 8 manual connections and 8 outbound full relay comes, then you don't have slots for block relay, like 2 more, because all 16 groups are filled. If you're running on only NetStore or I2p or cjdns.
Okay.
So one way you could test it is like run a node on only netis is what? Tor. And then you could change those max group values.
Okay. And then see like it's not connecting to it. Yeah, it set connected got filled in and it's not connecting to new peers, something like that.
Yeah, what did I think I wrote it in the PR description. Did I? Oh yeah. Yeah, like if you change it to 17, you'll see that it's not possible because we don't have that many net groups.
Okay.
But yeah, that's a workaround to test it.
Doesn't seem like a very easy way to test it out though, but yeah, can be manually tested. Okay.
So what problem does this PR solve?
Exactly what we discussed now. Yeah, so on summary it basically solves the problem of like hitting that limit of 16 groups possible for privacy addresses, and because this semantically doesn't make sense, so we are unnecessarily bounded by 16 16 net groups for privacy only networks, whereas like we could like go on further and we should not require that bound. So this PR basically removes that bound um, by not setting the net groups for privacy networks.
Yeah, I mean, yeah, you don't add those groups for privacy networks into setConnected.
Yeah.
Yeah, we talked about this. Why skip NetGroup diversity checks when establishing outbound connections to Tor, I2p, cjdns?
Yeah.
Yeah, random addresses.
Yep.
Yeah. And what does fcount failure do?
So I think this is a parameter in address manager attempt connection. Yeah, and by the name of the variable, it seems to me like it counts the number of failures in attempting.
Yeah.
And but is it like relevant for this particular PR in any way?
Yeah. Like it's so it gets set here. Like this is fcount failure. This thing. The second parameter. So it's a goal. It'll some setConnected and outbound privacy network peers. So like we saw the logic now, right? In thread open connections. If it's failure inbound, we do not add it into setConnected. But if it's manual outbound block relay, we add it into setConnected if it's not Tor I2p CJDNS.
Right.
But if it is Tor I2p CJDNS, we have another variable called outbound privacy network pairs.
Right.
Which is initially 0, and you increment that value. So yeah, they're random, no relation to root. You don't need to worry about it. So yeah, so actually, like the first time I did this PR, I did not use this.
Okay. That variable, outbound privacy network peers. Yeah.
It was not there. So in my fcount failure, I just put setConnected.size greater than or equal to this thing.
Okay, and this was previously setConnected.size greater than equals to this guy. This bull is determining fcount failure.
Yeah.
Why? And like, why do we want to count failure with such a logic? Because
Okay, maybe first we should talk about why we should count failures.
okay, yeah, definitely, yep.
Yeah, so if we grab for yeah, so I think you talked about it. F count failure actually increases n attempts, a number of attempts. Where is that? Yeah, so basically that whole thing, it like you keep passing F count failure from where we started, like from in net.cpp we have that open connection thing, right?
Yeah.
So it'll keep getting passed until you finally end up with in this function attempt.
Right.
So in attempt, if F count failure, you will increment this n attempts.
Attempts number. Okay.
Yeah. So why do we increment n attempts? So if you grab for n attempts again, yeah. So what it does is like we want to deprioritize after each failed attempt.
Okay.
So if we try connecting to a node and we weren't able to connect to it, so the next time the adderman runs, you actually deprioritize it 66%.
Okay.
This is used in GetChance. So
okay, so this count is basically a metric that tells us like how much priority does this node has in terms of establishing connection. If a node has a lot of like failure count, then we are not very eager on connecting to that node anymore.
yeah, exactly. We don't want to connect to it.
Yeah, but my question was like, why do we do this selectively? Because when F count is false, then this attempt increment will not happen. So why do we want to do it selectively?
F count is false. Yeah, like I didn't get your question.
When the F count variable is false and it goes passed on to that attempt function, and in that attempt function, if F count is false, then info m last count at like info n attempt plus plus will not happen. So we will not increase the attempt counts.
Yeah.
So that priority function will also not work in that case.
Yeah, if F count failure is false, yeah, we do not increment that.
Yeah. So why do we want to make F count failure false in certain cases? Like that was my question.
Yeah. So imagine we just started our node, and it hasn't connected to anything yet.
Okay. 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 Basically, like this comment over here also probably explains that. So at the startup, when there is no network, we might have a lot of failure count.
Yeah.
Or if our network is down, we might have a lot of failure count. So in that case, we don't want to increase the failure count for those nodes. Oh, and it's comparing with standard minimum of max connection -1 or 2. So if we have 2 or less than 2 connections,
we do not record failures.
We will not record failures. Yeah.
We do not want to deprioritize any address from being selected.
Yeah, because it could be that our network is also down. It's not the peer is bad, it's just our internet is down.
Yeah.
Okay, that clears that up. Okay, thanks.
Yeah. Next one is also very related.
So why did we add the outbound that new variable?
Yeah.
I think that's the next question.
That's the next question.
Yeah.
Oh, sorry.
Yeah. Yeah, like what would happen if this wasn't there in the code? Yeah, so if this wasn't there in the code,
So like,
now, go on.
yeah, I think like you can explain it.
Yeah, so the problem is, okay, right now we have manual connections too. And okay, I'm trying to word it.
I think like the way to phrase it is like previously in the code, the number of like, so this logic is about understanding how many live connections we have so that we can set f connect of true to false. So previously we were like calculating the number of connections that we have via setConnected.size. But now we are like omitting the privacy addresses from setConnected.size. So the setConnected.size will not account for the privacy networks we are connected to. And that's what is the extra variable is adding up to that number. So instead of,
so like you told before, like we need minimum 2 connections. Like we don't know why the parameter 2 was chosen, but it was the threshold chosen.
Yeah, I think S. Doctor also like comments on that on this post below. After this Vasil D's comment is, can you scroll down a bit? Here, just here. Yeah. Yeah, so it could be 1, it could be 3. It's like up to people to find out if that makes like any difference or not. Like 2 is like as good as any other number.
So this is the total number of connections.
Yeah,
okay,
and then we are
one more
adding.
side question here. Yeah, so our intuition right now is we need our total number of connections to be greater than or equal to 2, and if it's greater than or equal to 2, that means we have enough connections and we should record error and failure attempts and deprioritize addresses from getting selected. So the side question here is, like, why do we need setConnected.size? Why can't we just add all the different kinds of, like the total count of all addresses? Why do we need setConnected.size?
Total count of all connected addresses.
Yeah, like all the connections, sum it up. So that should be greater than or equal to 2.
But setConnected could, setConnected is basically implying like the number of net groups we are connected to.
Yeah.
And it could be like total connection could be actually more than that.
Yeah.
And we choose number of net groups because that's more safer.
No. Yeah. So this is actually one very remote logic. Apparently, so we should go into GetGroup of, like, it's actually because of, like if your node is offline, you wouldn't be connected to online nodes, but it is possible that you would still be connected to offline, like nodes in your local network.
Okay.
So it's possible that if your node is offline, you are you have more than 2 connections. Like you might have 10 local connections, but none of them is online.
Okay.
And the GetGroup logic for says that all local addresses, they all belong to the same net group.
Okay.
So it's possible that we have 10 local
connections, but they all belong to the same net group. Okay. So.
Yeah. And if it's 10 local connections, should we record error and failure? We shouldn't, because the node is offline.
Okay, makes sense.
Yeah, so that is why for IPv4, IPv6, we are taking net group size and not all the connection size like Tor i2p cjdns.
Okay, get it. That clears that up. That was a nice question. Yep, we could also add it into our question list.
Yeah. Did everyone understand it?
Yes.
Great. Anmol?
Yeah, got it.
Okay. Yeah, and this one we already covered it.
Yeah. Why like 4 to 5 isn't desirable? Because it's gonna screw up the adder manager logic.
Yeah.
Okay. Cool. Yeah, seems like we covered all the questions. Any other questions anybody has around the peer? If not, then I'll also stop my recording. We are already at 1 hour mark, and so this was nice. Thank you, Stratus, for providing the details and the demo through it. And I'll also try to like post a review comment, and we'll come back again tomorrow next week with another PR. Probably next one gonna be a wallet related PR. And so yep, thanks everybody for joining. See you around.